Okay, exercise 2C, question 4. We've got this as our quadratic with ax squared minus 6x plus a minus 2 equals 0. A is not equal to 0, which is good because if a was equal to 0, this would not be a quadratic. Now they said the roots were, one root was twice the other root. We've called one alpha. This is common. Often you see this in a factorized form. If you had y equals a x minus alpha, so they often use alphas and betas or gammas, etc. if we're writing out linear factors, right, in this factorized form of the quadratic. Why is the root alpha? Why have I written minus alpha? Because if we make this equal to 0, then that would have to be 0, that would have to be 0. A is not allowed to be 0. For example, right? Hence the reason for the minus in the factorized form. Okay? Now, sum. These are sum and product of roots. The sum minus b on a. Okay. If I'm going to label these as my roots, the sum would be alpha plus 2 alpha. It would also be minus b on a. That would be minus of minus 6 on a, literally. So we would get 3 alphas equals 6 on a. We could divide both sides by 3. Alpha equals 2 on a. That's quite neat. We'll probably use that. Product of roots, c on a. Product of roots, alpha times 2 alpha equals c on a. What's c? Well, it's this. A minus 2, right? The constants divided by a. So that means 2 alpha squared equals a minus 2 divide a. This one I'm not so keen on rearranging. I'm going to call this equation 1 and equation 2. Equation 1's nice and neat. I've got a nice expression for alpha. Let's substitute 1 into 2, right? So where I've got alphas, they're now 2a's. 2 on a squared equals this. Can you see that we can now solve for a? Next, this is 4 on a squared times 2. 8 on a squared equals, right? 2 is squared, the a is squared. 4 on a squared times 2. A minus 2 on a. I'm going to cross multiply. I've got a fraction equal another fraction. So I'm going to times both sides by a. And then I'm going to times both sides by a squared. Okay. 8a equals a cubed minus a squared. A cubed minus 2a squared minus 8a equals 0. Too many a's. We can pull out an a from each of these. Each of those terms has a factor of a. When you want solutions, always factorize. Make the equation equal to 0, factorize, and this is making it easier to solve. So I need a product of 8, a sum of 2, 4 times 2, a minus 4, a plus 2, a equals 4, 2, 0? No. A is not equal to 0. Now, what does this mean? It means there's actually two quadratics where the roots are double each other. I think there won't be room to write it. I'm going to have to, where can I put this? Let's do it over here. A is 4 or 2? Right. Okay, A equals 4 or minus 2. Therefore, quadratic 1 is 4a squared, 4x squared minus 6x plus 2 equals 0. 4 Oh, I can't see it. Yeah, that will work, won't it? 2x minus 2. Okay. 2x minus 2. 2x minus 1. X equals a half or 1. Quadratic 2. A is minus 2. Minus 2x squared. Minus 6x. Minus 4. I should have done that here. There's a factor of 2 there. It equals 0. Let's simplify this. So what I've done is come through and I've divided by minus 2 everywhere. I'm allowed to do that with 0. It just equals 0. So just make sure you do it everywhere. Divide by minus 2, divide by minus 2, divide by minus 2, divide by minus 2. Okay? So, x plus 2, x plus 1 equals 0. X equals minus 1, minus 2. These are the roots. These are the roots. I should have done that here. I should have said, oh, all even numbers. 2x squared minus 3x plus 1 equals 0. Would have made it a bit easier. Don't forget, with a non-monic, what have you got if you want? If you want to use it, what's it called? Say it with me. Quadratic formula. All right, so I believe, I'm going to double check the question, but I believe it did ask for the roots. Question 4, find A, well there were two solutions, and the two roots of the quadratic equations. There were two quadratic, right? So there's a bit of work there in 4, but it's all, you know, the same sort of thing. Sum and product of roots. Thank you.